My backend works, my frontend works, but the moment I connect them, everything breaks. In this video I will show you why containers can see each other and how Docker Network fixes that. I have a small Flask backend image. It runs a web server and listens on port 5000. And I have a frontend container which is just Nginx. I'm running them the most basic way possible, no custom networks, no flags, just two containers. This looks fine until the frontend tries to call the backend. Let me get into the frontend container and try to curl the backend application. We got some bad response, and this is where most Docker network confusion starts. Here is a trap. Inside a container, localhost doesn't mean your computer. It means this container. So when the frontend calls localhost, it's just talking to itself. So our curl fails not because Docker is broken, but because these containers don't know about each other. They are isolated by default, and this is intentional. So the question is not why doesn't this work? The real question is how are containers supposed to talk to each other? This is what Docker networks are for. A Docker network is a private virtual network where containers can actually see each other. When containers share a network, they can communicate, they get automatic DNS, and they can reach each other by name. Think of it like Wi-Fi for containers. So now let's practice. Let's make our first network by using network create command. Also, we can use network ls to see what other networks we got. After that, we can use inspect command, which show us all information about this network. Right now, this network is empty, no containers are connected, so let's fix it. We will again run our containers, but now we will use network flag. Both containers are now inside the same Docker network. I'm not exposing any ports yet, this is internal container-to-container traffic. Let's again get into frontend container and try to curl backend. And it works just fine. I didn't configure DNS, I don't know the IP address, I'm just using the container name. Inside every Docker network, Docker runs a small built-in DNS server. When a container joins the network, Docker automatically registers its name and IP. So, inside the Docker network, container name equals DNS name. So now let's take everything we learned and put it together. A real backend, a real frontend, and Docker network between them. We have exactly the same Flask backend image. This is very simple frontend. When the page loads, it sends a request to API hello and prints the response to the page. Notice there is no host, there is no local host, no IP address, just a relative URL. We got nginx conf that serves the static frontend, but here is the key part. Requests to API are forwarded to backend 5000, and I will repeat again, backend is not a host name from the internet, it's a container name. And also we got Docker file for frontend. This image is very simple. We take nginx, copy the HTML file, and replace the default config. Let's build our frontend image. Note that flag F points to a custom Docker file, and flag T gives the image a readable name. Also, it's good to mention that dot in the end gives us the context where we can find our Docker file. Also, let's check that all images are ready. And again, we are creating our Docker network by using Docker network command. And now we can run our container. We start with the backend. Don't forget about network flag. After that, we can run frontend container. Besides network flag, we need to forward port to make application accessible from our machine. Now we can check the result. In the browser, we open localhost 8080 and it works. To sum up our experiment, the browser talks to the frontend talks to the backend, all through the Docker network. No IPs, no magic, just Docker networking. In the next video, we will take the exact setup, same backend, same frontend, same network, and replace all of this with a single Docker Compose file. Hope you enjoy. See you soon.